Oh, you know what? I just can't help but go back to this this YouTube video. There's a new video out there on entropy. I actually watched it last night. Oh, it's this one right here. So yeah, if you get a chance, it's a 35-minute deal, and it's I think it'll make you look at environmental impacts in a new way. And there's another one too.
Thermodynamics governs how the entire universe operates, and thermodynamics governs how the entire universe will end.
Because, you know, if you remember, guys, like the very beginning week or two of this class, we talked about thermo, and it's, anyway. So do take a look at this.
The two laws of
really
thermodynamics are
there's
fundamental
one
laws
more.
of physics. The two laws of thermodynamics are always true everywhere in the universe until the end of time.
This one's pretty good too. It's actually, I don't know if I've got, yeah. This one is really good. If you get a chance, just take a look at it. So those are two sort of well, the Russian one is quite good and quite technical and good graphics. The Carlin one gives you a whole different perspective. So anyway, these are two different ways that I think we can effectively communicate with the non-specialist on this. Okay, week 13 reading assignment though. Chapter 9. Page 205, let's take a look here. Yeah. Okay, there we go. Chapter 9, 205, environmental impact of the bioeconomy. So much has been made of the negative environmental impact of using fossil fuels. The assumption has often been made that anything that reduces the use of fossil fuels will automatically benefit the environment. This reality is much more complicated than at face value. So, for example, agriculture has been blamed for the desertification of Africa, while demand for fuel wood is clearly responsible for the deforestation of Europe. So, and we get in this conversation a lot with my forestry colleagues about what's the best way to manage the forest, and I don't think that it's possible for us to just never go and cut another tree down. The question is like, which one, where, when, why, and how. So, there's a little bit here on biotechnology. I just finished reading Dick Manning's Against the Grain, where he sort of questions the use of big agribusiness. But the picture right here is showing how humans ourselves, of course, we're part of this biological cycle of grain development, and in a lot of ways, if you do genetically engineer a grain, and I think wheat is given here as a pretty classic example, well, maybe not in this figure, but wheat was made much more efficient in that the plant itself, sort of, if you remember Mendel's peas from your genetics class, the plants themselves were shorter, so there was less metabolic energy going into growing the stalks. The heads were fatter, and they were all about the same length, which makes it easier to harvest. You're sort of more bang for your buck. The question is, well, gosh, is this really what we want to be eating? And I've even heard that sometimes when there's a food crisis or a drought in another part of the world, the leader might say, we don't want genetically modified foods, and sort of forcing his population to starve rather than potentially be poisoned or damaged or mutated from the perceived threat of genetically modified organisms. So that's what they're talking about, frankenfood up there at the top of page 206. Yeah, and so they mentioned the chain of events necessary for a plant DNA to jump ship into human DNA is unlikely and has not yet been observed. So it's a little bit on genetics. Page 208 talks about production. And it's kind of agriculture writ large. One thing that's worth noting, I've recently come to realize, is that the United States Department of Agriculture is sort of a subdivision of the Department of the Interior. I've also learned that the U.S. Forest Service is a subdivision of the U.S. Department of Agriculture. So it's almost like, you've got the interior here, which is the United States, the agriculture, which is a subset of that landmass, and then forestry, any forested land has the potential to be turned into arable land, I think is kind of the point. So I've just recently kind of learned that hierarchy of how the whole thing works. What's that?
I think it should be the opposite.
Yeah, you would kind of think that agriculture sits under forestry instead of the other way around, but it's just where we are right now. So I'm just going to read here a little bit. It says, agriculture can have either positive or negative impacts on the environment depending on how it is practiced. Early cultivation of cotton and tobacco in the southern U.S. was notorious for quickly depleting soil fertility, requiring frequently opening of new lands. And here's what is meant by soil fertility. So page 209. Soil fertility is primarily a function of the amounts of organic carbon. So the graphene we were talking about before would not be an accessible form of carbon. Nitrogen and phosphorus, as well as potassium. The amount of organic carbon in the soil increases or decreases from year to year depending on tillage practices. And you'll even see that right out here. And what I don't know that much about agriculture, but anytime you have disturbed soil, you're sort of inviting other non-native seeds to come in. I think that's why we see so much dandelions in the soil that was disturbed for the building of these two buildings. And now you've got, a couple different choices. Do you spray a herbicide on them to get rid of them and put in something either more attractive or sustainable, unless you like dandelions? Or do you, do it mechanically, which is what I usually do.
Actually, dandelions are super beneficial to bees because they are one of the first things to bloom in the spring.
Oh, really? So the bees are able to make nectar from that? Huh? Yeah.
Killing off all the dandelions is just a bad thing for bees.
Oh, interesting. Okay, that's good to know.
Because they have that huge spring bloom, and then they kind of go away for the summer.
So it gets the bees off to a good start energetically.
After the winter.
Nice. Okay. Yeah, here's another one. It says, organic carbon affects soil fertility in several ways, including increased water retention capacity and gas permeability. So the soil itself does have to breathe. That's why you see people kind of aerating soil. And improving the availability of inorganic nutrients. So those would be your magnesium, iron, other microminerals that need to be there.
Now, would you like the carbon capture from the biomass, but would that be accessible carbon? Because I know you talked about putting that carbon back into the soil.
Yeah.
Just more putting it in the soil to sequester it versus actually use it.
Right. That's a good question. If you're getting a nice, clean CO2 stream off the biomass, and we expect that we will. In fact, we should know that pretty soon because we've got the 5-gas analyzer coming here shortly. My suggestion would be that CO2 just gets pumped back into the greenhouse, and then it's used by the plants in the greenhouse. I have seen, I have seen some agricultural practices where the exhaust gases from the tractors is just sort of used in the tillage rather than just going up in the stack. It's actually kind of, I don't want to say pumped underground. It's not like pumped underground. It's just sort of injected with the tilling. And yeah.
Wonder how that affects the micro layer.
Yeah, I don't know. I mean, I just don't know. Nitrogen is always an issue. It says corn, for example, is notable for its demand for nitrogen, requiring the order of 135 kilograms per hectare per year, compared to only 50 or 60 for herbaceous crops. The issue with a lot of times with putting nitrogen on the soil is that it's not all used. Yeah, it ends up as runoff, and then like this, you end up having these algae blooms that suck all the oxygen out of the water and sort of kill everything around it, and eventually it dies too. There's no perfect solution, because what you end up with is, if you don't supplement with fertilizer, then you have a lot of land that's not as efficient as producing crops, and therefore the small farmer tends to go out of business. So this accelerated race to put more and more chemicals on crops to increase the yield, so it's more efficient and thus more economical.
Yes, because with big A, you don't get that biomass layer in the fall to get naturally put back in.
Right. Yeah, big ag just gets addicted to those chemicals and stays on that cycle.
That's tough.
Yeah. I noticed something similar, my own backyard, whoever lived there before, I think he pulled out the fruit trees and just started a lot of grass. It was very lush, very rich, but I haven't put any fertilizer on it. Now it's just conked out, just dry, and I need to start.
Septic, I usually helps.
No, there's no septic allowed on city limits anymore. But what I really love to do would be to get some aeration going back there and just start putting some of my compost back on it. I think that would help a lot. Any time to do that.
Actually, grass is very inefficient.
I know. I don't want to be a grass farmer.
Let's turn our yards into farms.
I like that. Either farms or little bird sanctuary.
Watching the thing, California, they're designing solar. It's like a half circle, and essentially they're creating it to create some electricity, but primarily there's water shortage in California.
Oh yeah.
But it's not necessarily a water shortage, they just don't have fresh water. They have tons of salinated water in the valley, so they're going to use that to desalinate the water.
Oh yeah,
It's pretty cool.
yeah, it's a. Well, are they making electricity with these evacuated tube devices?
I think they're making enough electricity to self-sustain the system itself.
For desalinating.
It's primarily for the desalination of the water.
Yep.
It's pretty crazy.
Well, I mean that's what we're finding too in some of our clean coal discussions is you know that there are going to be valuable elements in that coal ash. The problem is getting the clean energy into the system to separate the components. So same thing with your desalinator. Where does the energy come from? And yeah, if you get it straight from the sun, that's how to do it. It's the sustainable way to do it.
I think there was either pecans or almonds that they had to physically rip out like half of their trees because they didn't have enough water to sustain.
Oh,
the
man.
tree.
Yeah. Yeah. Well, I had a lot of water in my backyard. I don't know how effective it is to start piping Montana water to California, but
Just about rained Arizona, so.
yeah.
That lovely little system to LA.
Yeah.
The worst part is it's like an open system.
You have evaporation going the whole way.
Yeah.
Yeah.
Put it over the mountain range. What man does.
Yeah.
Sometimes.
Yeah. Yeah. Well, this chapter is also talking a little bit about global warming. It certainly mentions CO2. It says as plants grow, I'm just looking on page 215, as plants grow, they absorb CO2 from the atmosphere and convert it into carbohydrates, oil, or proteins. If the above ground plant material is harvested and used for bioenergy or fuel, CO2 is returned to the atmosphere with no net carbon emission. If the above ground plant material is harvested and processed into biominerals, such as plastics, you might even think of that as being carbon negative because you're not pumping it back up into the atmosphere. So the plant itself sucks the carbon dioxide out and then it just remains in a solid form rather than going back up into a gaseous form.
We should line all our roads with hemp.
Yeah.
Suck up some CO2.
Mm-hmm. Then come along and harvest it. So the hemp becomes the sequestration. I like that. And you kind of,
They use a lot less water than but these great trees down the road, but then half the time they die because they don't have enough water.
mm-hmm.
Then it's gonna be a dry summer.
Yeah, maybe.
We're going.
Well, it's been a pretty good spring, but yeah, I hope we keep up the precipitation. Okay, so here's heat and power. The environmental performance of biorenewable resources for the production of heat and power is generally superior. That's the environmental performance to fossil fuels. Nevertheless, both kinds contain contaminants like nitrogen, sulfur, chlorine for coal, and then heavy metals if you're doing municipal solid waste. And I think, well, I'm working with a team out of Canada that's got a pretty good process for removing these heavy metals, so you can sort of get your technosphere and your biosphere back from a landfill.
Now, can we capture these metals and actually use them? Because most of these metals are used.
Yeah, that's the idea. But again, the energy to drive the chemical reactions has to come from somewhere. But lead's a commodity, mercury's a commodity, cadmium's a commodity. I mean, they all have a use. It's just the demixing that's the issue. We talked a little bit about NOx in here. So N2 plus O2 is 2NO. Big greenhouse gas, nitrogen oxide.
Is that the same as the NOx they use for scuba diving?
Let's see, that's nitrous oxide, and I think nitrous oxide. I think that's NO2.
Yeah, it says nitrogen dioxide is NO2, nitrous oxide is N2O.
N2O, there you go. Yeah.
So it's close, but it's more nitrogen.
Yeah, and I don't know exactly what goes on with the N2O once it's in your body. I think it might just displace some of the other pathways and just make you lightheaded and dizzy because your body's expecting to have oxygen there and it's just not, so you get lightheaded and dizzy from that. Okay, what else? Chemicals for transportation fuels is in here. Sulfur emissions are still an issue with Bioenergy. Fibers come back, pulp and paper.
Maybe another good thing for you.
VOCs, volatile organic compounds can also be a byproduct. So, if I were you reading this chapter, just go ahead and know what each of the section titles are, look at some of the chemical reactions, know what all the acronyms are, because those are the type of things that are going to be on the test. And let's see, did I kick off forest thinning before? Let me see. Let me do it. Okay. So what I'm thinking here is, would you want to cut a bunch of little paths? Would you want to cut some kind of pattern, clear cutting? Obviously, clear cutting, at least I believe, is going to have a much greater impact on wildlife habitat, and I think you're going to run a greater risk of soil erosion too. So, let's look at that. There might even be some articles out there. What is going on with Lubert. I think I spelled that right. Let me check. Yeah. Yeah, it's up on Route 200. Okay, that's about all I've got for today. Cruise through the chapter, take the exam. I also, just so everybody knows, I went ahead and extended the deadline on that week 8 quiz. Okay.